Hello there and welcome to this tutorial. In this tutorial we're going to cover a beginner lesson in Godot. We're going to make this very simple game. This is Pong from the 1970s, where two players play against each other to bounce a ball backwards and forwards, and when you miss you lose a point. There's a lot of concepts to cover in this, but this is a really good start to learning how to use the Godot Game Engine to make some simple games. So let's get started. We're going to assume that this is your first Godot game, or that you're a Godot beginner, so we're going to go right from the beginning. So please play this in double speed if you already know some of this stuff. We're going to go straight to making a new project. So I'm just going to click on New Project. I've given myself a location for my Godot project, so you're welcome to do that too. And when you give it a name at the top, you'll be able to, I'm just going to call this one Pong Tutorial. And when you give it a name at the top, you just click Create Folder, and it will make a folder in that location that you had by default, and then you click Create and Add. Inside the view, when you're here, there's a 2D viewport, a 3D viewport, which we're not going to be using, and the script viewport. So we're going to jump to the 2D, and we're just going to make ourselves a brand new 2D scene. The way Godot works is very much based on the hierarchy of scenes. So by default it gives you just like very little resources, so it's not cluttered in any way. I'm just going to create this 2D top level scene. I'm going to select it again, click on it again, and I'm just going to call it game. This will be my top level scene, and everything will go underneath this. It's often a good idea to organize yourself that way, so that you've got you can actually put scripts on the top level scene that can look down into the children within it, but I'll cover that a little bit more as we go through this. So what we want to do is just get ourselves organized by getting something that we can start moving around, and I can introduce some of the main concepts. So what we're going to do is we're going to make a child object of the main game here. So by right clicking on game, click Add Child Node. Now there's a bunch of different options that you can find. The way that Godot works is that the nodes are the things that do the magic. There's lots of different nodes within this node 2D that you can see, and they've all got different jobs and different roles. If you're coming from a different game engine like Unity, these would all be components, but the way you organize yourself within Godot is that you make them children of a top level, and which means you have to kind of pick the top level object fairly sensibly. You would think that the best thing to use here would be a sprite, and we certainly could. However, with the sprite, it's just a general purpose thing for the visuals, and it's not actually got any collisions or anything attached with it that makes a collision. The one that we're looking for is actually called an area 2D. That way, if we hover over things here, it says 2D area for detection and physics. So we're able to use this to help us to detect collisions. So I'm actually going to create an area 2D first up. So I have created this. I'm just going to rename this to ball. And you notice I'm keeping everything lowercase. In the programming language itself, which is like Python, it is convention to keep things lowercase, so you'll see why we do this, why I do this later on. A lot of tutorials that you see will have these as capitals. We want the actual sprite to be a child of this, so we can see it. So right now you can see it up the top here. And oh yeah, while we're here, these exclamation marks, these give you an idea of the problems. When you create certain nodes, they require that there are children nodes. You can see this area 2D will only work if it has a collision 2D node as a child of it. So either a collision shape 2D or a collision polygon 2D. So I'm going to actually add the sprite first so that I can get a better idea of the size of this. So I'm going to right click on Add Child Node, and just at the top I'm just going to start typing sprite. See, there's a few different options. I'm just going to use the static one rather than the animated one because it's not actually going to be animated. So once we've got the sprite added, you'll see it's a child of ball. You can fold them away like this. The sprite itself hasn't got anything on it, and if we look across on the right hand side of our inspector, on the right hand side of the screen here, the texture says is empty. And you do need to find the texture. You can use this drop down and load a texture if you want to, Or one of the easier ways is just if you've already got one in your resources, you can just drag it across and drop it down into that box. So now we can see we have the actual visual sprite on top of this area 2D ball. The ball's still complaining that it doesn't have a collision area, so let's just do that too. So we're going to add a child node, and I'm just going to type in collision shape. So I started typing in collision. I'm looking for this collision shape 2D, and this gives us some basic shapes. Everything within Godot is all built in, so all the help is here. If you hover over things, you get tooltips for everything, and you can also see more information about it down below. And if you do happen to get the wrong type when you're adding them, you can actually change the type to something different. So I'm going to use this collision shape 2D, and on the top right hand side again, if you read this error message, it is again complaining, saying that there is no shape for it, and that's because we haven't said what shape we want this to be. So on the right hand side, we'll just change the empty, use the drop down, and go to this new rectangle shape 2D. Over on the sprite here is the shape appears, and I'm just using the scroll wheel to zoom in and out and pressing the middle mouse down to move around. I'm just going to drag this corner one out till I get to the top, and the bottom one as well, so we get this whole thing that the shape covers this the whole sprite, so it's as you'd expect. Now, when you're moving this around, one of the cool things that doesn't happen in some other game engines is because if I try to select this, I'll actually get the collision shape, which is not what I want. I want to be able to kind of like lock this so that everything here is selected. The whole ball is selected when I click on the object in the 3D view. And on the toolbar here, there's this funny button. I wouldn't even know how to explain it. Sort of like a sort of sideways figure of 8, but this one allows me to not select any children. So because it's attached to this thing here, when I click on the ball, I'm actually going to only be able to select the top level parent, the ball. So I'm able to move it around, and that does save a little bit of time and confusion. So I'm going to just zoom out and move this ball into the middle of the scene here. And we're almost ready to start programming. So I can fold those away now that I know that everything works, and we'll get into writing our first piece of code. So we're going to write our first piece of code on this ball here. If we click on the ball, you'll see in this scene view here, we can click this attach a new or existing script to the selected node. You could actually make one in your resources and then attach it, but I'm just going to click here to add a new script. By default, it gives it the same name as the naming of the nodes. If you haven't renamed it before this, it would probably be a good idea to make sure it is named. I'll just cover some of the other things here. The GD script is a great language. It's one that you should be the first one that you would pick. You'd think Visual Script would be good, but it's actually takes a lot longer to write stuff, and the syntax in GD script is so simple that that you shouldn't really go anywhere else for this. And obviously there are other options, but we'll stick to this GD script because it's nice and simple. This inherits box here is this gives us the functionality. So the area 2D has a bunch of things that it can do, and we'll cover that when we go into the actual script itself. We can have some different templates like completely empty or no comments. I'll leave it as default because it would be a good opportunity to explain what's going on. And then I'll leave the ball name, ball.gd is the name of the script. I'll leave that as default as well. If you do need to get yourself organized with files and folders, you can also choose different locations to place them by hitting the little folder over here. But for a simple project like this, we'll keep it simple by just leaving it all in the same spot. So I'll click create, and I'll be faced with the script editor to get myself started. So make sure that you save the actual scene as well. I'm just going to go scene and then save scene, and because I did that automatically, I saved mine as game.tscn. Before I start changing the scripts and stuff, it's probably a good idea to make sure things have saved. So again, just go to the scene, save scene, and then give it a name. And the scenes are tscn files, and they get saved in the resources as well. So we'll go back to the script, and I'll show you go through some of the important things about the script. This one of the key cool features that I feel within Godot is that just by holding Control down, if you find that you don't know what something is and you hold Control down, you can click on it and you can get full documentation. This is the built-in documentation for this Area 2D that I've just clicked on. There's a bunch of online tutorials that use it and show you how to use it. And there's also some properties. And with this Area 2D, you can access any one of these properties. So for example, you wanted to access maybe the gravity, you can actually access it inside of the script. So I'll go back to the script by clicking over here. You'll see that I can actually just type in gravity and it does actually come up as a in code completion. And all this stuff is just straight from this Area 2D object. We have some code comments in here. So when you're writing code, it's a really, really good idea to put code comments in. And you do them the exact same way as you would do in Python with a hashtag. And then you can type something in. This will keep you right. The code comments that you have here describe an example of creating a couple of variables. So var is the variable keyword. So if you did want to create a variable, you just type var and then the name of the variable. Obviously you want to name something better than that, and then you can set values for the variables. Now the key concept of variables is that each variable has a specific type to hold some specific data. So for example, if you needed it to hold the number 10, you could just assign the value of 10 to this name of variable. You can also put in strings. For example, this name of variable would now hold the string name, and there are many other types of variables that you can use. We're going to introduce these as we start worrying about how we're going to get this ball to move around. So I'm going to delete these code comments because I kind of don't need them right now. The next important concept is that inside of game engines, when the game starts up, there's almost always a ready, so when the game's about to start. Inside of ready, you would do stuff like initializing variables, or finding components within, or finding different parts of your game within here. You might even spawn stuff in. If this was, say, a game script spawning in some enemies, you might spawn some in on ready. This happens at the very beginning of your code. In order to test this, we can do something simple like printing out a statement. So if I do the classic hello world and then remove this pass, the pass is only there so that because the function ready needs to actually do something. So because we've got this, we can remove pass. I'm going to delete that as well. So by doing this and saving it with a Control S, when I run this scene, so if you click run, it'll ask you, this is to run the whole game. So the run on the top right here, the play button, this is play the whole project. If you do this, it'll ask you which scene you would like to run. You're welcome to do this and set up the current scene as the scene you'd like to run. But the other way of doing it is actually just to play the scene. So the shortcut key is F6, where you can just tap F6 and it will run the current edited scene, the scene you're currently on. You'll see when this run, because we've got a script on the ball and the ball is on the scene, that script run the ready method, the ready function here, and it printed hello world. And you can see down the bottom in the console in the output here that hello world did come out. So it's pretty obvious that that's going to happen. I'm going to hit stop here and then just look at the next concept here. So if we have a function that we want to run every frame, we want to run the process function. If you start typing in func and then an underscore, you'll see that these are all the ones that you can do, and you can scroll down these. So these all have their different reasons for being used. The process one is the one that runs as fast as it can every frame. So if I choose it and press enter, it will fill it out for me, so I don't have to type the whole thing out. The func process does pretty much exactly the same as an update function maybe does in Unity, this will run every frame. So if I copy this and paste it into the process, I might actually remove it from here so we don't get any confusion and use this password so that we can leave that in. And I've just pressed Control S. So by doing this, you'll see that this process runs every frame, and let's just test it and see that it does. So you'll see Hello World is coming out, and it's continually getting more and more and more. As every frame goes past, it prints out Hello World. That's the absolute basics of the way that this works. These are the most common ones that you'll use, and the other common one that you'll use if you're using rigid bodies or physics stuff is there's a physics process, which is also common. You might wonder what the delta is. The delta is if you hover over, you'll see, but the delta is the length of time since the last time that this ran. If you want to be running on different computers, it's a good idea to use this delta value, because this might be a really fast computer, in which case the delta value would be very small, and you want things to move in, pixels per second or a page per second, rather than just depending on how fast the computer is that's running it. So you do often use this delta value to make sure that things do run at a consistent rate across all sorts of different computers. So let's get to making this ball move. So the ball itself, if you see in the inspector, the ball itself has a transform with a certain position. It's currently at 520 by 296, so 520 on the X and 296 on the Y. And you'll see as I move it around on the screen that as it comes towards the top corner, that's 0, 0. So top left is 0, 0, and the furthest right on this is a sort of like a default setup. I think it's 1024 for the default setup. And if I just zoom out and move it down to the bottom, you'll see that the highest Y we get to is 600. So the screen goes from 0, 0 in the top left down to 1024 by 600 by default. So if I just drop it back in the middle approximately, we need to kind of understand that, because we're going to want to be able to control where it is and where we move it. And this transform itself, we can write some code. The property for this, as you can see, is its position. If I go into my code, what I can actually do is I can actually move it just by using the translate. So there's a bunch of different functions that you can run on things. This translate function, if I just double click that, if I hover over, hopefully, or we'll hit Control and click on it, we can take this to the actual documentation. So translate gets given as a parameter a vector2, and we haven't really covered vector2 yet, so I'm going to just quickly show you that. But it basically translates the node by the given offset and local coordinates. So translate means moving it, and we need to give this translate this vector2 in order to know where to translate it. So if I jump quickly back to the script again and Control S, the vector2 is just an X and a Y. So if I want to pass in a vector2 to this function, I can actually just type in vector2 and then open another set of brackets, and then it's just two values, an X and a Y. So if I just say, for example, 10, 10, and I save that and we run the scene, what you'll see is that the sprite zips at 10 by 10 every frame across down and to the right, because we're adding on to X and to Y. If we want to play around with these values and maybe say -10, -10, you would expect it to go top to the top, up and left. And if we just run it, you'll see that it does. This variable, this value, what we should really do is we should really make this a variable. So I'm going to create a variable at the top, and I'm going to call this speed, and I'm going to make it equal to that vector2 that we just did. This I think I actually quite like that it goes right to start with, and I quite like that it maybe doesn't go, make it go down by a little bit, so I'll use the value of 3, and then inside the translate I can just type in speed. By saving this and running it, you'll see that everything happens exactly as it did before. Why I've created a variable is for a couple of reasons. It makes my code a little bit cleaner. This hopefully shouldn't change throughout the whole game, so I shouldn't really have to make this new vector every single time. But the key reason why is because sometimes you'll want to have the variable visible inside the inspector, and by typing in the word export, you'll see now I've got my ball selected and I've typed in the word export. On the top right hand side now, it says script variables. Now because I made a script variable called speed, you can see these values are in here. So without having to go into my code again, I can actually tweak these values and change them, and I can make them bigger or smaller and run my code, and that will be reflected inside my code. And the last major problem I did mention that I want to solve really quickly is this delta value. So when we translate by speed, what we want to do is we want to multiply that by delta, so that its speed is independent from the speed of the computer you're actually running on. What you'll find now is, because delta is going to be a very small number, so what you'll find now is that these values will be barely perceptible as the thing is moving, but it's just moving so slowly that it's hard to see. So oh yeah, I do want to remove this print as well. So what we can simply do is we just make the values bigger. Now because I've changed it over here, now these ones overwrite these ones. So I will need to change them over on the export side over in the inspector. So rather than make them, I'll just make them quite a bit bigger. So I'll try 500 and I'll try 30 or something like that, and then just hit go and see what it looks like. So it is moving. So our next major issue is, how do we get it to bounce? We're in the process here and we're translating it, but what we really need to do is we really need to, rather than when it gets to the side of the screen, rather than continue moving in that direction, we'd love to be able to make it bounce. Well, let's get started on doing that. So all we really need to do is we need to check the position. Now the Area 2D, if I quickly look at that, it's got a bunch of properties all relative to the actual Area 2D and the collision and stuff. But within that, if we look in the what it inherits a collision object 2D, and it also inherits this node 2D, and each of these properties are accessible within the actual code for that object. So it can work its way down the hierarchy. You'll notice that, so I clicked on node 2D, which is pretty much everything. It's pretty much used for absolutely every 2D component, including sprites and stuff like that within it. So this node 2D has a position value, and weirdly enough, this will just literally find the position of the object in pixels on the screen. So we can use this position value, which works as the local position, or we can use the global position. This global position, if we click on it, I'll explain that you can get and set the global position of this object. So if I go back to the script again, what we should be able to do is we should be able to test this. One of the best ways of being able to test things is just to print the statements out. So if I print the global position inside this every single frame, and I might actually make the speed go down a little bit, and then I'm just going to run this. So what you'll see is down the bottom, you'll see these values change. And when we saw this before inside the 2D view, that when we get to about here, we do want to kind of go the other way. So in English, we want the speed to basically be inverted. So the x speed, when we get to this end one, we want to make it negative if it's positive. And if we're coming this way and we hit the edge, we want to again make it positive instead of negative. And in maths, that's as easy as just multiplying it by -1. So I want to have a little look. So I reckon about 990 is where I want it to bounce. And on this side, it would be 32 is where I want it to bounce. So I'm quickly going to jump into the script and we're just going to check those. So I can simply use an if statement to kind of like find out what that position is. So I'm just going to say if global position dot x is greater than, and I think I chose 990, then I want to make the x component of the speed, I want to invert it by multiplying it by -1. So I'm just going to type in speed dot x, and I'm going to use the shorthand here by using times equals -1. This times equals is shorthand for writing speed.x equals speed.x times -1. And when you have to do this a lot of times in your code, it doesn't make sense to have to do it every single time. So all you'll do is you'll take that part out and you put the times before the equals, and that's just the shorthand version of saying speed equals speed times -1. So by doing this, what we should see if we test this is that when this global position dot x gets greater than 990, the x speed should be inverted, should be multiplied by -1, and then this process runs again, and then it translates by speed again, which has just changed. So let's test this and see what happens. So when we get to 990, it turns around and it goes the other way. So we need to solve the left-hand side one as well. If you feel like a challenge, you can stop the video and you can try and get that to work as well. If you want an extra challenge, you can try and get it to bounce off the bottom and the top as well, to see if you can do that without any help. If not, you can leave the video playing and I'll solve it anyway. All right, so we just look at the global position again. So if global position dot x is less than, I think I said 30, I think it was 32 or something like that, then we want to do the same thing. We want to do speed dot x times equals -1, and that will invert the x position. Always a good idea to test as you build, so I'm just going to quickly test to make sure it does actually work. So it bounced on the right hand side, and now it should bounce on the left. It's probably not going to bounce on the bottom because I haven't written the code for that yet, so it's pretty simple as well. So again, we're just looking for the global position. This time it's not the x, it's the y, and I want it to be greater than, let's have a little look. If I go back to my 2D, and I'll move it down, I'm looking on the right hand side, so 568 sounds good, and at the top it's 32 again. So back to the script, I'll say 568, and I want to make this time, we don't want to change the x speed, we want to change the y speed, and we'll say times equals -1, we'll just invert it, and then we'll do the same for the top. So global position dot y is less than 32. We'll want the speed dot y to be multiplied by -1. So hopefully, if we try this out, we should be able to see that it bounces on the top and the bottom, hopefully, and both the sides as we go. So the code's not too difficult. What we're actually seeing is that we've just got a bunch of if statements and we're using the global position. So we've covered a fair amount of concepts already, just getting this ball to bounce. And we'll move on to the next part, which is getting player input, so we can actually have the paddle to bounce the ball off as well. Alright, to make the paddle, we're going to add this as a child of the game. So I'm just going to add another child node. And I'm going to do what I did the last time. I'm going to make an area 2D as the top level, because I know I'm going to probably need to detect some collisions as I go. So I'll create this as an area 2D. I'm going to add a child node of sprite again, and I'm going to keep the graphics really high end, and all I'm going to do for the sprite is I'm going to drag on this icon again and just drop it back into this sprite texture. The area 2D is still complaining because, as before, it needs a collision shaped 2D, so we'll just quickly do that. So I'm going to add in the collision shape 2D and change the shape from empty to rectangle shape. Just zoom into this so I can see what it's going to look like. I want this area 2D, I'm going to rename that. So you just click on it again to rename it, and I'm going to call it paddle for now, and leave all the names of these other things. So we've got the top level one is set correctly. So the sprite itself, I think what I'd like to do with the sprite is make it maybe twice as big, and I could drag it up and drag it here, but you'll notice that the center kind of gets a bit off. So just Control Z those. You can actually change the scale just from this transform component over here. So I'm going to make the scale 0.5, so it's a bit narrower, and I'm going to make the size of it twice as big, and that keeps the center exactly where it should be, so it's right in the middle. The collision shape needs to also match, so again I'm just going to kind of like eyeball this one. It doesn't have to be too flash. For this, I'm sure I could probably do it a more accurate way, but I'll just move these out so that it's approximately correct. So I have my paddle set up, and all we need to do now is set it so that we can't accidentally select the children like we did with the last one. So you remember from the ball, we can click on this funny weird symbol which allows this to be locked so that it can only select the whole object. So when I click on it, it selects the top level object, and then I'm just going to move it down into where I kind of want it, approximately about the middle of the screen, and then we'll write ourselves a script for it. So I have the paddle selected. I'm just going to hit the plus up here. This script again is going to be a classic GD script with an area 2D that it inherits. Remember that the area 2D is also a node 2D, so I do get some of the code availability from the node 2D as well, and we'll leave it as a default name for paddle and hit create. As before, I'm just going to get rid of some of these comments. They do kind of get in the way a little bit when we're doing this. So when you first start writing code, you should be concentrating on just building the code up and doing one thing at a time. So the one thing that I want to do right now with this paddle is literally just make it go up and down. And from the last script, from the ball.gd, we know that we created a variable of speed, and that was a vector 2 the last time. On this occasion, we can actually just have a single floating point value, a single number that will be the speed that will go up and down. So if I go back to paddle, I'm going to create a variable and I'm just going to call it speed, and this will just, we know we're only going to move in the y-axis, so either up or down, and I'm going to set this to something like 500, because I'm going to actually remember from the last time, I'm going to multiply it by delta so that we have it in pixels per second rather than having it as a smaller number here. So the ready function we kind of don't need just now, so I'm going to actually delete it, and then I'm going to create my standard process function. And remember from before, this one happens every frame, so we basically want to move up and down, but the key concept that we're going to bring in this time is the user input. So in order to get the user input, there's a few different ways to do it. The project settings has this input map. By default, there's a bunch of inputs that have been set up already. So you can see that each one has a name, UI-page-up or UI-home. And we can set our own up. I think since we're here, we'll do it anyway. So I'm going to say P1 and then underscore and then up. And then I'll do P1 underscore down. These two actions appear down the bottom of the action editor. And by hitting a plus, you can assign one or more keyboard or joystick or J-axis events to it. So I hit the plus there on P1 up, and the key that I want for that is W. So I'm just going to press the W when this dialog comes up and click OK. And then for the P1 down, I'm going to do the same, hit plus. I'm going to say key, and then I'm going to press the S key. So I'm going to be, the player 1 on the left is going to use W for up and S for down. Now, how do you access those? Well, inside of Godot, there is this input class. The input dot allows us to do things like check if an action is pressed. So we've created those already. We can see that there's different ones that do different things. And again, you can go straight to the documentation in Godot and find out what each one does. I want this is action just pressed means it will happen just that one frame when it is just pressed. Then the same for just released, but this is action pressed means that it just checks to see if it's down or not. So I'm going to select that. You'll notice that because I've already created the actions, they come up here. So I've got this P1 down or P1 up. I actually want to choose the up first. And this, if we see this, returns a Boolean or a true or a false. So what we can just do really simply is we can say if before that. So when this gets called, if this is actually down, if whatever key's been set up for this action is down, then it will return true, and so we'll get to do code inside of this if statement right here. So we want to just basically move up. So from the last time, we remember there was this translate that you could have. There are other options that you can do for that. You can actually use the move local y as well. And this is just a single value. So if we look at this function, move local y, it says how much would you like to move? And then it's got whether you're going to be scaled or not if your object happens to be scaled. So this move local y, we'll give this a go and see if it works. So we want to go up the way, and as we know, that's a negative value, so the 0, 0 is in the top left. So we want to do minus speed times delta, and that should, in theory, just move this object upwards by the value of speed times delta. So it's all a good idea to test this before we move on. So just hitting the plus, and I'm going to press the W, and you'll see that it does actually shoot straight up off the screen. So we'll do the down before we worry about stopping it. So I'm just going to say again, this if input, and we're going to use the is action pressed again, and we're looking for the down now. So because it's in an if statement, if this is true, then we'll do this little bit of code, and I'll write myself a quick code comment just to remind myself what's happening. And I'm going to use this move local y function again, and this time because we want to move in a positive direction, that's adding values on, we'll say just the positive speed, and we're going to multiply that by delta again so that it's frame independent. And then just quickly test to make sure it works. So just pressing W and the S key, you'll see that it does actually work. So the next major problem that we need to solve is making sure that they don't shoot off the screen when we try and move up or move down. Currently, if you're pressing up, it will constantly move, even if it gets off the screen either by moving up or moving down. So one of the simplest ways of doing this is to do another condition. Basically, in the other script, we check the global position. So the global position.y, if we check the position to make sure that it is on the screen, or it's not too far away, then we should be able to move only if we are still within the bounds that we're looking for. So if I go to the 2D and I'll try and work out what I want, so we'll do one at a time. So if I'm moving up, so what I want to do is got the paddle selected, I'm just looking at the position. So we don't want it to be moving beyond about 60. So as long as the position is greater than 60, you should be allowed to move up. So let's just test this. I sometimes get confused about which way around it goes. So the way we can do it is we can just do this AND statement. So this means do this and that. And so we'll say and the global position. So global position dot y is greater than 60, I believe. Just quickly test, because I do, as I mentioned, I do sometimes get this the wrong way around. So I need to quickly move this back into position because it was already too low down. So I'm just going to move this up. So you can see that I can go up to the top, but it stops. So it doesn't actually move because the value that you can see over here is, click back in, the value is less than 60. So I do know that this is working, so I can continue with the next part of the code. So if I just quickly go to 2D again and just move this down and see where I want it. So 500 and about 536 it says, which is a weird number, but we'll do it anyway. So we want to check this condition. So we'll say and global position is less than 536. So we want to make sure that it's within that bound. If it goes greater than that, we don't want to be able to do this. So we want to make this fail. And I just saw the error there because I need to check the actual y part, not just the whole thing, which is a vector. So just quickly check those. So if I go up to the top, I don't go any further, and down the bottom, I don't go any further. All right, so that's a success for getting those paddle moving up and down with a variable for its speed. The next thing we want to probably do is we want to get this paddle to bounce off the ball so that we are able to detect that. And in that, we're going to use some signals. All right, in order to detect the collisions, we're going to introduce a basic concept inside of Godot of signals. If I select the ball, you can see over here that in the inspector tab next to it is a node tab. That node tab has these signals. These signals can be connected to other scripts inside of other objects on the scene, or they can actually be detected. Scripts can be directed back to the same object. And I'll show you what I mean, because what we basically want to do is we want to hook up this area entered so we can run some code when another object or another area enters it. So if they're overlapping, if the ball overlaps with another area, either this paddle or the other paddle when we put it in, then this piece of code that we choose will be fired. And basically we just want to bounce for now. So this area entered, we're going to connect this up. So you can double click that and you can choose what object to connect to. And as I mentioned before, you can connect to other objects as long as you know that they're going to be on the scene. On this occasion, it's the ball that we're going to connect to. So you see it gives it a default receiver method. So this creates some code for us so that we can just use it. There is an advanced, but we'll skip over that for now. This already has a script on it. So all going to happen when we click connect is it's going to add this to the end of our code. This is the code we wrote on the ball before. I don't actually need that anymore, so I could get rid of it. So this is the code that was on the ball before, and this is the new piece of code that was written for us. So this on ball area entered will get triggered, whatever code we do, will get triggered when something enters. And as I mentioned before, it's always a good idea to test. And what I'm going to do is I'm just going to test by printing out the word boing to the console and get rid of that other piece of code. So by running this and testing it, what I should be able to do is, we'll see in the console down here, when this ball hits it, another area, which is our paddle in this occasion, then we do see the boing word gets printed out to the console. So we do know that that piece of code is actually working. That's obviously kind of not what we want to do. We want to actually bounce. If you look closely at the code, what you'll see is that we're kind of doing the same thing over and over here, and it's this thing that we want to do again. We could simply just copy this code. If I Control C and paste it in here, this would be fine. We would see that the ball would actually bounce. If I play this scene, you'll see that when the thing bounces into it, it will automatically just bounce straight off, or look like it bounces straight off. What would be better, however, is that we write our own custom function for this. So if I make a new function called bounce, which would be kind of what we're doing, which is a good name, and I use this speed.x times equals -1. If I use that, because we're going to do this over and over and over, and we may want to do other things too. We may want to play a sound. We may want to, I don't know, change the score or something. So this public, this function that we've created right here allows us to kind of like reduce code a little bit. Now I know it's only one line of code, but this is a good opportunity for using this as an example. In order to run a function at any place in code, you just use the name of it instead. So it kind of looks a little bit nicer, and it certainly is a lot easier to read, and it gives us a little bit more flexibility later on if we want to maybe do something else inside of this bounce. So where we're bouncing on the X, I'm just going to use, just going to call that function bounce. I'm going to leave the Y one right now because we could get complicated about doing it, but we could play a different sound, for example, but I'm just going to leave that as it is because it's not really complicated right now. But that just helps us to show how we can make our code a little bit more readable and a little bit more reusable just by adding in our own custom functions and calling them places in our code. So the next major problem that we need to solve is we need a second player. So we just need to basically copy this one. So if I Control C on this one and then Control V, we'll get a second paddle. It's copied it and put it in exactly the same place. So I do want to move the second paddle over the other side. That was just a simple Control C, Control V. Unfortunate thing though is we need to change one thing, because if you notice that when I move one up and one down, you'll see that they actually move with the same keys. So we kind of want to solve this problem. So have a little think about how you might solve this problem, and then I'm going to just quickly go over one of the different ways that we can solve this. So the last step I want to take in this video is I want to make sure that when the ball actually hits the sides, that the ball is reset back to the middle. Currently, when we bounce off the sides, we actually just bounce and the game continues. But in the real game, it actually just resets back to the middle. So we're quickly going to cover this as the last thing before we do. In another video, I'm going to do the scoring because it's not quite as simple as some of the other things. So we'll go back to this script here. So when we actually go off the sides of the screen here, we call this bounce function that we made. But what we want to do is we want to reset. Now, one of the key things that we want to do is we want to actually store the position of the ball at the start. So if I say create a new variable called start position, I'm just going to call it start pause, so I don't need to type it all out. And then I'm just going to make it equal to like a vector 2, and I can use a .0 to make a vector 2, which is just 0, 0. By initializing the variable here, you're actually telling this what type of vector, what type of variable it is, so that it does know it's going to hold a vector. So the start position has an X and a Y now. Inside the ready function, which we got rid of, I'm just going to bring this back. So the ready function happens at the start. We're just going to say that the start position is equal to the position of this object. So when the game actually starts, we'll reset this start pos to the actual position. So when you position this anywhere you want, at the very start of the game, when you hit the play, it will just store that position so that we're able to put the ball back there when the game has, or when it's touched one of the sides. So the start position for now is kind of all I want. And what I'm going to do just to keep things neat and tidy is I'm going to make a function, because this function is probably going to do more stuff later on. And I'm going to say reset ball is a good name for the function. Now this reset ball function is all it's going to do is it's going to do the reverse of what we've done here. So we're going to turn the ball's position, make that equal to what it was at the start. So it's kind of like the opposite of that. So rather than bounce, we want to do this reset ball. So I'm just going to do this here. Just going to type in reset ball, and I'm going to type in reset ball again, so that we're able to, instead of bouncing, just reset the ball. Now it might be okay as it is. We could you could extend this if you wanted to. If I hit play and I play this right now and the ball hits, you'll see that no matter what the ball's velocity is when it does actually hit, it stays the same, which is not necessarily a bad thing. You could actually reset or add to the reset function and make the velocity a little bit different, so reset it to a different value, because as it is, it's still a little bit predictable. In fact, just for a little bonus, what I might quickly do is just do the random as well, so that we get a little bit of randomness every time we actually bounce, which gives us a way to make this game a little bit more fun. It's really a lot easier than it seems. All you really need to do is, when we bounce, the speed.x, we negate that. We make it, if it's positive, we make it a negative. If it's negative, we make it a positive. But what we can actually do is just change this value of the speed.y, and we can add on a certain amount of randomness. So there's actually a really cool function called rand_range, which, as you can see, takes two values, a from and a to. So that's basically a minimum and a maximum. And what I can do is I can, I know these values are currently around about the 30. So what I might do is just test this out. I might say that it's maybe -10. I might try -5 and then +5, so that every single time we bounce, we'll get a little bit of random value added to the y velocity. So if I test this out, you'll see that we shouldn't be quite so predictable as it bounces, because we might get a little bit more up or a little bit more down when it bounces. If you want to see the extreme of that, what we can do is really make this real big. So if I make this -50 or +50, so every time we bounce, this value does change. We should see sort of like a wee bit of a difference as we bounce against these things, where we get a little bit more or less y or y velocity. See how it went up quite steeply that time? So I think actually, to be honest, the 50 is, because it's not moving that fast, I think somewhere between -50 and +50 actually works quite well. That adds a little bit more randomness to the game. So as I said, in the next video, we'll be adding in some scores so that we're able to make this game like a little simple competitive game against two people, as a good introduction to learning the Godot game engine.